the objects shown on the screen are in motion. Some motions can be a uniform motion, while others can be a non-uniform motion. Now today, in this video, we are going to see the graphical representation of motion. To describe the motion of an object, we can use line graphs. So first, let us see the distance-time graph. A straight line along the x-axis represents time, and a straight line along the y-axis represents distance. Let us assume that the object is in uniform motion. That is, it travels equal distance in equal intervals of time. For the first 20 minutes, the distance traveled by the object is 10 kilometers. Now for the next 20 minutes, the car travels another 10 kilometers. And for another 20 minutes, the distance traveled by the car is 10 kilometers. And so on until the car travels 60 kilometers in 120 minutes. So in this case, the graph of distance traveled against time taken is a straight line as shown in the figure. The portion OB of the graph shows that the distance is increasing in a uniform rate. Can we determine the speed of an object using the distance-time graph? Well, yes, we can. Consider a small part AB of the distance-time graph. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now on the graph, can you say which line denotes the time interval? Yes, AC denotes the time interval T2 minus T1, and similarly BC denotes the distance traveled S2 minus S1. It means that the object moves from point A to B and travels a distance S2 minus S1 in time T2 minus T1. So as we know, speed is given by the distance traveled by time taken. So here, the speed will be given by S2 minus S1 divided by T2 minus T1. Now, look at this graph. Is it different from the previous graph? Yes, the previous graph was for uniform motion, and the graph that we see now represents motion with non-uniform speed. So students, we have seen what is distance-time graph, and now let us discuss about velocity-time graph. As we know that if we specify the direction of motion of an object along with its speed, it is called velocity. Velocity-time graph. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time will not change, and it will be a straight line. Now, the distance moved by the car from A to B between time t1 and t2 is drawn. The velocity of 40 km per hour is represented by height AC and BD, and time t2 minus t1 is represented by length AB. So, the distance S moved by the car in time t2 minus t1 is given by S is equal to AC into CD. That is the area of the rectangle ABDC. Now, consider a case of uniformly accelerated motion. From the table, we can see that initially the car is at rest, and after every 5 seconds, the increase in velocity is 9 km per hour. So there is a uniform acceleration. So the distance moved by the car can be determined by the area under velocity time graph. That is, S equals to area of ABCDE, which gives us the area of rectangle ABCD added with the area of triangle ADE. So students, what does this velocity time graph represent? Yes, it represents the non-uniform variation of velocity of the object with time. This is an example of non-uniform acceleration. So today, we have learned to describe the motion of an object using distance time graph and velocity time graph.